Okay, so we were discussing the consumer price index, right? So in this chapter, we will be looking at inflation, and we have already defined inflation as a sustained increase in the cost of living. Now, in class last time, as I recall, we examined exactly what the cost of living was, because each of us has a different cost of living. So how does the government speak of the cost of living as if there were just one cost of living? As I mentioned in class last time, the government has in mind an average American, right? The Bureau of Labor Statistics, the Bureau of Labor Statistics conducts expenditure surveys, just as it conducts a labor market survey in order to arrive at the monthly unemployment figures. It also conducts an expenditure survey, and they go about asking people questions about what they spent their money on. What do they buy? What consumer goods do they buy? And based on this, the BLS arrives at what is called a market basket. A market basket of goods and services. Now you can think of this as a shopping cart that is full of the kinds of goods and services that the average American consumes, right? So this here is a basket or cart, and it contains goods and services consumed by the average American. So hence we can speak of the cost of living as if there were just one cost of living. You see, the government has in mind an average Joe, and this is what the average Joe lives on. Now in this basket are everything from aspirin to tires for your car, correct? Housing, entertainment, food, etc. Everything's in here, correct? And what is the cost of living then? The cost of living is the cost of this basket. In other words, the number of dollars that it would take to buy this basket is the cost of living, correct? Now this cost of living, and I'm going to use the acronym COL for cost of living. Now the cost of living in the year 2013 would be expressed in what kind of dollars? Firstly, what is that cost of living in 2030? That would be the money it took to buy this shopping cart full of goods and services in 2030, correct? So of course, this would be measured in 2013 money, right? This is what the basket cost in 2013, so that is the cost of living in 2013. Now, this same basket might have cost something different in 2014 because of various prices rising. The cost of living tends to go up from year to year, correct? So this same basket would cost something else in 2014. Of course, that would be measured in 2014 money, right? Now, what is percent inflation between 2013 and 2014? Now, that is calculated as the percent change in the cost of living between the 2 years. Now, how do you calculate percent changes? Percent changes are always calculated as new minus old divided by old times 100. That's how percent changes are calculated. You take the actual change, which is the new value minus the old value. But then you express that as a percent of what the value used to be, the old value. right? So going by that, what would be the inflation between these 2 years? Well, you would take what's new and what's old. This is new, of course, correct? And that is old, right? So percent inflation then would be the cost of living in 2014 minus the cost of living in 2013 divided by the cost of living in 2013 times 100. That's inflation. That's percent inflation, which in the US has been running at a little bit under 2% a year for the last couple of years. So the cost of living has been going up about 2% a year. Right? Now let me tell you something important, and that is that this cost of living, the actual dollar cost of living, isn't reported by the government. The government doesn't typically report the cost of living. So how are you and I to figure out, to calculate inflation between 2 years? You see, what the government reports instead of the cost of living is something called the Consumer Price Index, or CPI. This is what the government typically reports. Now, it is based on the cost of living, but it isn't the cost of living itself. It's based on it, and let me explain what the Consumer Price Index is. So what is the Consumer Price Index? Well, the formal definition is that the Consumer Price Index for any year T is the cost of living in year T expressed as a percentage of the cost of living in the base year. That's the formal definition of the Consumer Price Index. It's the cost of living in year T expressed as a percentage of the cost of living in the base year. Now, what is the base year? Have we encountered that term before? Someone? When have we last encountered the phrase base year? When we were talking about real GDP, correct? So do you remember what real GDP was? How do we calculate real GDP? We took the actual physical production of goods and services in any year, apples and oranges, so many pounds of apples, so many pounds of oranges, and we value these at the prices from the base year. That's how we arrive at real GDP, correct? So we already know what the base year is, roughly. It is a year against which we compare other years, right? So mathematically speaking, then, what is this going to be equal to? This is going to be equal to the cost of living in year T expressed as a percentage of the cost of living in the base year. That's how you express something as a percent of something else, isn't it? Right? So this would be the cost of living in year T as a percentage of the cost of living in the base year. Let me warn you that your next exam will be full of mathematical problems. There'll all be little sums you'll have to do for the next in the next exam. Okay? So this is the Consumer Price Index for any year. Right? Now let me just ask you a question. What is going to be the CPI for the base year itself? What is that going to be? Given this definition, given that we have this definition here, could you work out the value of the CPI for the base year itself, quickly? Now, what would be the CPI for the base year? Wouldn't it be the cost of living in the base year expressed as a percentage of the cost of living in the base year? In other words, the cost of living in the base year is a percentage of itself. Look at the definition up here. Look at the definition of the CPI. The CPI for any year T is the cost of living in year T expressed as a percentage of the cost of living in the base year. So in other words, if this year T were to become base year, then we would change this to base year. Is that correct? So what would this look like? It'd be the cost of living in the base year expressed as a percentage of the cost of living in the base year. So what would that be then? Wouldn't it be the cost of living in the base year divided by the cost of living in the base year times 100? Are you following me here? And what is this equal to, somebody? Well, these two would cancel out. You'd be left with 100, right? So the consumer price index for the base year is always 100 by definition. Now let me make up some fictitious CPI numbers here, okay? So let's say that I'm going to make two columns, year and the value of the CPI. Okay, year 2000, 2001, 2002, 2003. I'm just making up these CPI numbers. This here is 97, this is 100, this is 104, this is 107. Looking at these numbers here, could you identify the base year? Well, the base year is going to be 2001. How do I know that? Because the value of the CPI for 2001 is 100. And we know that, as I've just explained, the value of the CPI for the base year is always 100. So 2001 is our base year. Correct? Could you interpret quickly this 97 for me? Could you interpret this? In other words, give me a sentence with the 97 in it that explains to me the meaning of that number. What does that 97 mean? Somebody? Now, wouldn't you say that this 97 means that the cost of living in 2000 was 97% of the cost of living in the base year? Base year meaning the year 2001. Correct? Isn't that the meaning you get from that 97? By the definition of the CPI, right? And what meaning, by the same token, would you make of this 104? Could you interpret this 104? What's the meaning of that 104? Well, that would mean that the cost of living in 2002 was 104% of the cost of living in the base year. Right? Now, what's another way of saying 104% of? Could we express this slightly differently? Could we not alternatively say that the cost of living in 2002 was 4% higher than in 2001, meaning the base year? Something being 104% of something is the same thing as saying that's 4% bigger, isn't it? Right? Therefore, could you calculate for me the percent inflation? What is percent inflation between 2001 and 2002? What is percent inflation between 2001 and 2002? Well, what is inflation defined as? What is inflation defined as? Now, isn't inflation the percent, isn't it this? The percent change in the cost of living between 2 years? Right? Now, what is the percent change in the cost of living between 2001 and 2002? What does this last statement here say? It says the cost of living in 2002 was 4% higher than in 2001. Correct? So, therefore, what's percent inflation between the 2 years? Isn't it the 4%? Isn't that what inflation is? The percent change in the cost of living? Yes? So 4% then is the rate of inflation between 2001 and 2002. Now what is that 4%? Now isn't that 4% the same thing as the percent change from 100 to 104? In other words, the percent change in the value of the CPI. Now, how do you calculate the percent change from 100 to 104? Now, isn't that going to be 104 minus 100 divided by 100 times 100? New minus old divided by old times 100. Right? And in this case, the two hundreds would cancel out here, so you'd be left with 104 minus 100, which happens to be the 4%. Correct? So what am I trying to tell you here? That even though inflation is defined as the percent change in the actual cost of living, which is what it costs to buy that market basket of goods, right? Even though inflation is the percent change in that actual cost of living, we can also calculate inflation as simply the percent change in the value of the consumer price index. The consumer price index, in other words, can stand in for the cost of living, even though it isn't really a cost of living. The consumer price index isn't a dollar figure at all. It can represent the actual dollar cost of living, right? So bottom line here then is that percent inflation may be calculated as the percent change in the value of the consumer price index. And the consumer price index is something the government reports. The Bureau of Labor Statistics, in fact, reports the value of the consumer price index. It does so by the month. You have a CPI value for every month, and then you have an average for the entire year, right? Coming back to these fictitious numbers that I have put up here, could you calculate percent inflation between 2000 and 2001? Somebody quickly? What would be inflation between these 2 years? Would it simply be 100 minus 97? Would it be 100 minus 97? No, it would not. Why wouldn't it be? In this case, it boiled down to 104 minus 100 simply because the two hundreds canceled out. Now, that is not going to happen in this case. Because in this case, inflation would be new minus old. That would be 100 minus 97. 100 being new, 97 being old. Correct? Divided by 97 times 100. And these two things are not going to cancel out in this case. Do you follow me? So it's not going to be 100 minus 97. It's going to be something else. You can calculate that. I leave it to you. Now, how would you figure out inflation between 2002 and 2003? What would be percent inflation between those 2 years? Well, that would be the percent change from 104 to 107. That would not be 107 minus 104. It wouldn't be that. It would be 107 minus 104 divided by 104 times 100. Yes? So we now know that the CPI can be used to calculate percent inflation. Right? So that is one of the most important uses of the consumer price index. We can use it to figure out inflation. We can work out, calculate the percent change in the cost of living from 1 month to the next or from 1 year to the next. Okay? Let me now give you quickly another important use. Another important use of the consumer price index. Another use of the consumer price index is we can use the CPI to compare nominal dollars across time. And let me show you how to do this quickly. Now, we all, in all our families, we have elderly relatives who will tell you that in the good old days, things were so cheap. Is that correct? We've all met people like that. Right? So let's say that your grandfather tells you that in the year 1975, the price of gasoline was 30 cents a gallon, right? And what are we paying for gas today? These days, the price of gas, of course, is currently quite low, right? I'm not sure that's sustainable. But today the price of gas is, can somebody tell me a figure? Unleaded gas? $2.12. Can we compare these? Is your grandfather, in fact, correct by saying that since 30 cents is less than $2.12, gas was much cheaper back then? Is he correct in saying that? Yes or no? He's not correct in saying this. Why? Because he is comparing two different currencies. This here is a 1975 dollar. This here is a 2014 dollar. The two may not be compared. They may not be compared because they are really different currencies in terms of what the money can buy. Back in 1975, a dollar was a lot of money, much more so than it is today. And that has to be taken into account, correct? So you can't really compare these two numbers directly. How would you compare them? How could you compare them? Well, it's the problem we had with comparing nominal GDP across time. We couldn't do that either, right? Correct? So what did we have to resort to back then when we were discussing GDP? In order to figure out whether our economy is growing, what did we have to do? We would have to take nominal GDP from this year and compare it to nominal GDP last year. But how would we do that comparison? We would have to convert the nominals into real, am I correct? Only real dollars can be compared across time, because real dollars are, what are real dollars? What are real dollars? Real dollars happen to be base year dollars. So we need to convert these two different currencies into a common currency called real dollars or base year dollars. How would we go about doing this? I'm going to show you a quick way of doing it using the values of the CPI for these years. And let me make up some numbers here, okay? So let's say that the value of the CPI in 1975, let's say that number was 85. And let's say the value of the CPI in 2014 was 230. So what are these numbers? These are the values of the consumer price index for these 2 years. Okay? What meaning can we draw from this 85? What is the, how do we interpret 85? Somebody quickly? Well, the cost of living in 1975 was 85% of the cost of living in the base year. Now, we haven't been told what the base year is, but that's all right, as long as we know that there is a base year out there. Right? So this 85 means that the cost of living in 1975 was 85% of that in the base year. And what does this 230 mean? The 230 means that the cost of living in 2014, which is what it takes to buy that, the money it takes to buy that market basket of goods and services. Well, the cost of living in 2014 was 230% of the cost of living in the base year. That is 130% bigger. Right? Now, if I were to quickly draw a timeline here, and I put 1975 here and 2014 here, where would I place the base year? I don't know what the base year is. But could we perhaps use some logic here to place the base year somewhere? Would the base year be, for instance, would it be there? Or would it perhaps be somewhere between these numbers? Yes. Now, why would you go with that? Why would you go with that? Because we know that the value of the CPI for the base year is 100 by definition. Am I right? And remember that the CPI stands in for the cost of living. It represents the cost of living. And we know that in the US, the cost of living has only been rising over time. Am I correct? So if I were to make a graph of the CPI like this, and if this is 1975, which makes this number here 85, and this is 2014, and that number there is 230. So where would my 100 be then? The 100 is here, correct? And that basically then takes us here. So that's our base year then. Do you follow me? Since the number 100 lies between 85 and 230, we can conclude that the base year lies somewhere in between these two numbers. Now, we don't know what the exact year is, but that isn't important either. It isn't important. Right? So how do we arrive again at this conclusion? From the fact that the cost of living, or the CPI, has been going up over time, historically. Right? So this is the base year then. So what we need to do is we need to convert these 30 cents of 1975 money into base year dollars, and we need to convert the $2.12 of 2014 money into base year dollars. Right? How do we do this? Well, let's go back to the CPI. Now, if the cost of living in the base year, if the cost of living in the base year were $100, the cost of living in 1975 would have been how much? Can somebody tell me? Had the cost of living in the base year been $100, in other words, if it took $100 to buy that market basket of goods, what would that same basket have cost back in 1975? How much? Come on, somebody. Wouldn't it cost $85? How do I know that? Because I know the cost of living in 1975 was 85% of the cost of living in the base year. Now, if the cost of living in the base year is 100, what's 85% of 100? 85, isn't it? So the cost of living in 1975 would have been $85. And the cost of living in 2014 would have been how much? $230, since 230 is 230% of 100. Are you with me here? So we can now make the following, and I'm going to go to a new blank page here. We can say the following. We can say that $85 of 1975 money are equal in value to $100 of base year money, and that is equal to 200 and what was it again? $30 of 2014 money. These are equivalent values because you can buy the same market basket of goods with these sums. Correct? So in terms of what money can buy, these are equivalent figures. Right? Now, can we not use these to construct an exchange rate? Let's focus on this first, this equality here. So we have the following. We have $85 of 1975 money are equal to $100 of base year money. So can't I then ask the question, what would one 1975 dollar be equal to in terms of base year dollars? How do we work that out? How do we make the 85 into a 1 and then correspondingly reduce that 100? Well, we are going to have to prorate. Is that correct? So we would do the following. We would divide this by 85 to arrive at the 1. And we'd have to divide that by 85 also. Isn't that right? That's how one prorates. So what does that come to, somebody? Can somebody with a calculator quickly tell me what this is? I need to proceed a little fast. I have 15 more minutes to finish a little substantial bit of this stuff. Quickly, somebody. 1.18? 1.18 base year dollars. Correct? All right, now let's look at the other equality. So we have 100 base year dollars are equal to 230 2014 dollars. Can I not ask the question now? What would one of these be equal to in terms of base year money? Once again, we would do what we did just now. We would divide this 230 by 230 to make that 1. And we'd have to divide that by 230 also. Right? Quickly, can somebody tell me what 100 divided by 230 is?
0.43.
How much?
0.43.
0.43 base year dollars. So we have the following then. We have this exchange rate, that's 1. And then we have this exchange rate, which is the other. And they are the two exchange rates we need to convert nominal dollars into real dollars. So let's take your grandfather's 30 cents price of gasoline in 1975. Let's convert that into base year dollars. How would we do that? How would we convert 0.30 1975 dollars into base year dollars? Somebody? Well, what's the exchange rate? Well, one 1975 dollars is equal to 118, right? So really, we'd have to multiply 0.30 by 118. Am I correct? Let's leave it in fractional form, by the way. Let's leave it in the form 100 by 85. Okay, instead of rounding off already. Can somebody tell me quickly what that is? How much is that? Do we have an answer? Quick.
0.354.
0.354?
Yes.
Is that correct? Anyone else confirm that? Okay, let's proceed. So this is, what kind of money is this? Right? Now let's take our current price of gasoline, which is how much? How much was it again? 212. And let's convert that into base year dollars as well. What is the relevant exchange rate now? One 2014 dollar is equal to 43 cents of base year money. So what would $2.12 of 2014 money be equal to? Wouldn't that be equal to $2.12 times 0.43? Or let's leave it in fractional form. Yes? And what is that equal to? 0.91. What kind of money is this again? Base year dollars. So your grandfather's price of gasoline was that much. Your price of gasoline is that much. So your grandfather is correct in saying that gas was cheaper in his day. Do you follow me? But the point is, we can't really compare the 30 cents to the 212. That you can't do. You have to do this first before you can compare those sums. Is that understood? So this is how we compare dollar amounts across time. Okay? Let's quickly now come to the issue of comparing nominal GDP across time. Okay? So we have a GDP figure. We have a GDP figure for 2014, a nominal GDP that is, and we have a GDP figure for 2013. So this is 2013 GDP and this is 2014 GDP. And we want to work out percent economic growth. We want to calculate percent economic growth. And percent economic growth is the percent change in real GDP. The percent change in real GDP. These are nominal GDPs. You can't compare them. So you'd have to convert these into real first, right? And we know how to do that. We'd have to take the physical quantities of goods and services and convert them into dollar values using base year prices, correct? But there is another way of doing it, which I'm now going to talk about. And this involves something called the GDP price index, also called the GDP deflator. So just as we have a consumer price index, we have something called a GDP price index. And how is the GDP price index different from the consumer price index? You see, the consumer price index does what? The consumer price index tracks changes in the cost of buying that market basket. And what is that market basket? Well, that's based on what the average American lives on. And of course, the average American mainly buys consumer goods, toothpaste and things of that nature. Now, GDP includes toothpaste. So the GDP basket would include everything that's in this basket, but it would include something more. And what would that something more be? Somebody? What does GDP include that isn't in this market basket which the average American consumes? Can you think of a final good that is part of GDP but that isn't bought by consumers? How about construction equipment? How about earth-moving equipment? What would you categorize these things as? Machines. And aren't machines a final good? And that's part of investment spending in the economy? So in other words, GDP contains stuff that isn't in this basket. So the GDP basket, if you can call it that, is a bigger basket. It contains more than what's in here. But otherwise, it's the same thing. We are tracking a basket, the GDP basket in this case. We're tracking changes in the cost of that basket over time. And that will give us the GDP price index. Right? So we have a GDP price index, also called the GDP deflator. Now, notice something here. How do we do this conversion here? In each case, we multiply the nominal dollar by a fraction like this. What's common about these two fractions? The number 100 is on the numerator slot. And what is that 100? That is the value of the CPI in the base year. And what is the denominator equal to? That's the value of the CPI from the year from which the nominal sum comes. You see? So this 30 cents came from which year? 1975, right? And so this is the CPI in 1975. Correct? Now this here was what? This is, again, the CPI in the base year. And what's this? That's the value of the CPI of the year from which this nominal dollar sum came, the $2.12. Where does that come from? Which year? 2014. So this is the CPI for 2014. So that's how we convert nominal to real, right? And we're going to use the same principle now to convert nominal GDP into real GDP. So we would say then that real GDP for any year t is equal to nominal GDP for year t times 100 divided by what? Divided by the value of the GDP price index for year t. Right? So we're using the GDP price index instead of the C price index, or the consumer price index. But otherwise, the procedure is the same. So this is one way then of converting real GDP into nominal GDP. So in order to perform this calculation here, we'd have a first step. And first step would be, you would have to convert both of these into real GDP. That would be step number one. And once we've done that, then we would calculate percent economic growth as real GDP in 2014 minus real GDP in 2013 divided by real GDP in 2013 times 100. Right? That's how one calculates percent changes, right? New minus old divided by old times 100. Yes? Now, very, very quickly, I'm going to quickly talk about certain biases in the CPI. That's all that I will have time for, but I'll have covered, really, the substance of the chapter. So what are the biases in the CPI? Some economists argue that the CPI overstates inflation. If you use the CPI to calculate inflation, you would be overestimating inflation. In other words, true inflation would be less than what the CPI tells us. And what are the reasons for this? Well, one of them is what's called product quality. Bias, and you might even clump that together with something called new goods bias. So what do we have? We have a basket here, correct? And it's full of goods and services that the average American consumes. Now in this basket is cars. Now let's say that we were trying to track changes in the cost of this basket for between, let's say, 1975 and 2014. So the basket in 1975 contained a car also, and the basket in 2014 contains a car also. But are they comparable cars? Are they comparable cars? Which one would you say is a superior car in every way? The car of 2014, I would think, given all the technological advances that have been made in terms of safety, fuel economy, comfort. Correct? So we are talking about two different cars. So yes, the car in 1975, a brand new car, you could have bought for, say, $5,000. And a brand new car today costs, $25,000 to $30,000, the same type of car. Right? And you might say, well, $25,000 is way bigger than $5,000. 5 times as big, in fact. So there has been a lot of inflation between these 2 years. Correct? But if you say that, you would be making one mistake, and that is, yes, today's car is more expensive, but it is more of a car. So you're paying extra for the quality. Do you see what I'm saying? So by that token, then, the consumer price index, in a sense, overstates inflation because it doesn't take into account the fact that goods today are, yes, some more expensive than goods in the past, but that's also because they are better goods. Right? And new goods, you can think of new goods bias in the same way. Back in 1975, what was the way to listen to music in a portable way? Could you carry your music around with you? 1975 is, I was 7 years old. I mean, let's move ahead a little to the 1980s. Okay? How do people listen to music, carry it around with them? You had the Sony Walkman, exactly, which was a little tape player, right? And before that, you'd have people with boom boxes on their shoulders and so on, correct? And now we have all kinds of fancy devices, that are much better, more convenient, right? So in the category of entertainment and in that subcategory of portable music, we now have a whole new category of goods that weren't there in 1975, right? So if you think of portable music players, well, what we have today is far superior than what was there in the past, correct? So yes, today's device is more expensive than that old boombox, but that's because it's a much better device and you can do much more with it, right? So that's one reason for bias. The second reason is product substitution bias. I have about a minute. I'm going to just take a minute to finish this. Product substitution bias, and the third one is outlet substitution bias. And let me quickly talk about these two. Inflation is like a punch being thrown at you. Now, if a punch is being thrown at you, do you expect to be just standing there and not taking any evasive action and receiving the full brunt of that punch on your face? Is that how people behave? No, correct? So when a punch of inflation is being thrown at you, you are going to change the way you behave in order to minimize the impact of inflation. And what would you do then? One thing that you would do is you would change the way you eat, you consume. You would substitute cheaper cuts of meat for more expensive cuts of meat. Do you follow me? You might buy a good substitute for something that's become more expensive. And that's called product substitution bias. However, the market basket that this consumer price index tracks is a fixed basket. All the goods in it are exactly the same. So the assumption is that people don't change the way they consume in the face of inflation. But of course, that isn't true. Do you see? So the CPI, therefore, overstates inflation because the CPI assumes that people will stand there still and get the full brunt of that punch of inflation on their faces. Correct? Because they are not changing the way they consume according to the CPI, because the market basket is a fixed basket. Third, outlet substitution bias. And that is people may change the way they shop in terms of the kinds of stores that they go to. When inflation strikes, you might, instead of shopping at a fancy store, you might go to become a member of Sam's Club or something. You might shop at the dollar store more or something, correct? The consumer price index doesn't take that into account. So once again, it overstates the impact of inflation on us. It overstates inflation. Okay, now there is some other material here that I haven't covered, but I think I've got the substance of this chapter, and you are now capable of dealing with your MyEconLab homework on this chapter. Okay, we'll stop here today.